Here we're going to simplify each of the following so that the answer only has positive exponents. So looking at this first example, we have 2 times 4, regular multiplication, 2 times 4 is 8. Then multiplying bases means adding powers. So m to the 2 times m to the 5, 2 plus 5 is going to make it m to the 7. N to the first times n to the first, we're going to do 1 plus 1, we're going to get n to the 2. Multiplying bases means adding exponents, but multiplying numbers, we would do that as we always do. 2 times 4 is still 8, and then we just add the powers. Looking next door here, we have dividing bases. So dividing bases means subtracting exponents. So we have 6 to the 20 divided by 6 to the 5. So we would have 20 minus 5, which would get us 15. Now, a common question is, why don't those 6's just cancel so that the answer is 1? I might not write out 6 to the 20th, but if I show you maybe 6 to the 5th divided by 6 to the 3rd, why this doesn't just cancel to be 1. 6 to the 5th really means multiplying 6 by itself 5 times. So if we write that out, 6 times 6 times 6 times 6 times 6 times 6, we have 5 6's, and then 6 to the 3rd is multiplying by itself 3 times. And so it doesn't cancel out to be 1. We would cancel out as many 6's as we can, and we'd be left with 6 to the 2, which is the exact same thing we would have gotten by subtracting these. 5 minus 3 would give us 6 to the 2. So it doesn't just simply equal 1. We would do subtraction to figure out the new exponent. Looking back over on this side, we have 3 things being raised to the 4th power. First thing we have is a number out front. Now, normally we would know that it's a number if it was anything but -1. You know, if it's a -3, we don't typically forget about it if it's a -5. But when it's a -1, sometimes we forget about it. It's still a -1 there, so we're going to raise that to the 4th. Then we're going to do x squared to the 4th. So we're going to do a regular -1 to the 4th in our calculator to start, which is 1. And now multiplying these powers, because a power raised to power means multiplication. So 2 times 4 is going to give us x to the 8. And then this is a regular y, so it's y to the 1. 1 times 4 is going to give us a y to the 4. So -1 to the 4th is positive 1. Then we have x to the 8th, y to the 4th. A power to a power means multiplication, and of course we don't technically have to write that one coefficient out front. Either answer would be fine. Moving over to the other side, this is a much simpler problem. Anything to the 0 power equals 1. Anything raised to a 0 equals 1. So this whole thing raised to the 0 power is just 1. Now, typically when you see anything to the 0, you can cross it off and just write a 1 there, if that's helpful, since anything to the 0 does equal 1. Next one down here, we have to distribute this -2 power in here, and then also this positive 3 power into here. So just distributing that -2 to start. I'm going to have 3 raised to the -2. C to the -2 times 2 is going to give us -4. And then d to the first times -2 is going to give us d to the -2. Then we're going to multiply it by 4 is being raised to the 3rd. We're going to have c to the first 1 times 3 is going to give us 3. And then 3 times 3 is going to give us 9. A power to a power means multiplication. So starting with these numbers, I have 3 to the -2 and 4 to the 3rd. Well, 4 to the 3rd is going to stay on the top, but I'm going to put 3 to the -2 as being 3 to the 2 in the denominator. Negative exponents belong in the denominator. Then as far as these other letters, I'm multiplying bases, which means I'm going to add exponents. So c to the -4 times c to the 3rd, -4 plus 3 is going to leave me with c to the -1. Which means it's going to go in the denominator as c to the 1st, or just c. Next one, d to the -2 times d to the 9th. Multiplication means addition. Negative 2 plus 9, or 9 minus 2, is going to give us d to a positive 7. So that goes in the top. Now we can try to simplify these constants. So 4 to the third is 64. Then we had d to the positive 7. And 3 squared is 9. And then we had c, that was really to a negative 1, which is why we put it in the denominator. I would double check in my calculator. 64 divided by 9 does not reduce, so we are good leaving that as our final answer. We don't have any negative exponents, and we don't have any numbers that can reduce out front. Looking at distributing the next one over, that 3 is only distributed to the numerator. So I don't want to do it to the denominator. Only the numerator is being raised to the third power. So I have negative 2 being raised to the third. And then I have powers raised to a power, so I'm going to multiply them. I have 4 times 3, so I'm going to get k to the 12th. Then we have p to the negative 2 times 3 is going to give us negative 6. And then the denominator, we don't have anything to distribute. I'm going to leave it as 5, k to the negative 3, p to the 8th. Okay, so in the top, negative 2 to the third power is negative 8. So a negative number can stay in the top, just not a negative exponent. If that was negative 2 to the negative 3, I would move it into the denominator. Only move it to the denominator if it's a negative power, though. So negative 2 to the third is negative 8. Over, I have 5 in the bottom. So I'd grab my calculator, do negative 8 divided by 5, and hit math, enter, enter. And it doesn't reduce, so I'm going to leave it just like that. And now I'm going to deal with the k's. So I have 12 minus negative 3, which is going to give me 12 plus 3. I have k to the positive 15 power. And then with the p's, I have negative 6 minus 8. Division means subtraction. Negative 6 minus 8 is going to give me p to the negative 14, so I'm going to put it in the denominator as the 14th power. So I have negative 8 k to the 15 over 5 p to the 14. Moving down, I have another power to distribute to just the numerator. I'm going to do negative 6 squared. A to the first raised to the second is going to be 1 times 2 is 2. Same thing, b to the 2 as well, over 12a. So I'm going to do negative 6 squared is 36. And I have that over 12, so I can reduce that. I have a to the 2 divided by a, so 2 minus 1 is going to leave me a to the 1. And then we have b squared is going to stay in the top. Now the only thing to do here, 36 divided by 12, can reduce to just be 3ab squared. Looking next door, I'm going to start with these constants. There's no power to distribute to anything, so I just need to double check, are the constants reduced, and then combine the x's and the y's. So plugging into my calculator, 10 divided by 4, math, enter, enter, reduces to be 5 over 2. Now I'm looking at the x's. I'm going to subtract because division means subtraction. 5 minus 11 gives me negative 6, so it's going to be in the denominator as a positive 6 power. And then negative 6 minus 1 is going to be negative 7. So it's going to be a y to the 7 in the denominator. So we get 5 over 2 x to the 6, y to the 7th. Now, down below there, we have some powers to distribute to both the top and the bottom. So I'm going to do it to negative 5. That's going to get squared. A to the 2 times 2 is 4. And in the bottom, b to the 1 times 2 is 2. So lastly, I'm going to square out that number. So I'm going to get 25 a to the 4th over b to the 2nd. Last one here, we're going to do the same thing. We're going to distribute this negative 2 to each term. So negative 5 times 2 is going to be a positive 10. 2 times negative 2 is negative 4. And then negative 6 times negative 2 is positive 12. And now, is that my final answer? No, I have to get rid of negative exponents, so the only thing I have to move is that q. So p to the 10th is good. We still have r to the 12th, but we need to move q to the 4th to the denominator where negative exponents belong. And now it's simplified as a positive power.